Hey everyone, this is one of the most common interview questions for model-based design developers. What kind of code does Simulink generate for bus, mux, and trigger subsystems? It may sound simple, but understanding what happens after code generation actually shows how well you know Simulink and embedded C. So let's break it down in a clear and simple way. When you design models in Simulink, you are essentially building the foundation for automatic C code generation. The graphical blocks like bus, mux, and trigger subsystems are not just visual tools, they represent specific code structures once you click build. Each of them is translated into efficient, readable C code that runs on embedded targets. Well, a bus in Simulink is like a structure in C. It groups multiple signals, sometimes of different data types, into a single logical structure. After code generation, it looks like a typical C structure definition. For example, you will see something like this. Instead of managing multiple individual signals, the generated code neatly organizes them under one structure. This makes the code easier to read, maintain, and map back to the Simulink model. Well, a mux, on the other hand, combines multiple signals of the same data type into a single vector. In generated C code, it appears as an array. For example, it will look like this. This approach is compact and efficient, ideal for real-time systems where memory and speed matters. The mux does not create a new data type like a bus. It simply groups signals into a single numeric array. Well, on the other hand, a trigger subsystem executes only when a certain condition or event occurs, such as a rising edge trigger. In the generated code, you will notice logic that checks the trigger condition before executing the subsystem. It looks something like this. This ensures that the subsystem code runs only when necessary, optimizing CPU usage and improving runtime efficiency. It's a clean, event-driven implementation that aligns perfectly with the real-time embedded behavior. So in simple terms, a bus becomes a structure, a mux becomes an array, and a trigger subsystem becomes a conditional logic in the generated C code. That's how your Simulink model transforms into efficient production level embedded software. If you are preparing for an MBD interview, this concept is worth revising carefully because it shows both your Simulink understanding and how well you can relate it to actual code generation. And if you want to see a live demo of how this code looks in the generated files, stay tuned for the next video where we will walk through it step by step. Thanks for watching this video.